Is that intro sick or what?
Hey, what's going on, guys? Today we are talking about and showing you how to execute and use flash loans. Now, I know we've talked about flash loans in the past and how exploitative they can be.
Today, we're going to be talking about preventing flash loan attacks.
We need to remember that these are actually just tools, and that used in the right hands can actually do more good than bad. If your protocol is susceptible to a flash loan attack, it's not really the flash loan attacker's fault, it's really your protocol's fault in the first place. Doing flash loans can actually do a lot of fantastic things such as leveraged arbitrage or swapping collateral out of loan positions without having to repay the debt of the loan position. Building an arbitrage bot was actually one of the first crypto trading bots that I ever built, and this would be a way to do that leveraged in the DeFi ecosystem. So let's jump in.
Now, we are going to be using Brownie to actually deploy these contracts. So if you're familiar with Hard Hat or Truffle, don't worry, we are going to go over the contracts first and explain what's going on in the contracts so that we can actually use these in any framework that we want. Now, if you just want to go through the quick start on the Brownie mix here, you absolutely can. And if you could all just do me a favor, hit the subscribe button, hit the bell icon, putting out some top quality content here, and you definitely don't want to miss out. Now, before we even go into it, I'm just going to very crudely explain what a flash loan is in the first place. Now, traditionally, when you look at a loan or you do some type of loan, the simplest way to talk about loans is actually putting down some collateral. So on the left here, so on the left side, we have me. I want a loan. I got some collateral. Maybe this is my, maybe this is my car or my house or something like that. And I say, hey, I would really like some lended money. I will put down my house as collateral if you give me the money. Lender goes, great, your house looks awesome, or maybe your ETH looks awesome, or your car, or whatever. Here's the lended money. Now that I put some now that I put my house down as collateral, I clearly don't want to lose my house. And usually the lended money given to me is worth less than my house. So if I don't pay back, the lender will take my house. This is known as over-collateralized lending. Lending and borrowing here. Now that I have this lended money, I can do whatever I want. One of those things that I can do is what's called arbitrage. Let's say we have these two yellow exchanges at the bottom. One says ETH is $50 and another one says ETH is $100. An easy way for me to make money is to do arbitrage. So I take my lended money and I buy a ton of ETH at this $50 price and then I sell it at this $100 price. I've essentially just made $50. If I buy one ETH at $50 and then I sell that one ETH at $100, I've now just made $50. Now I can go back to my lender, say, hey, here's your lended money back. I get my house back, and then I have this $50 profit. Now, this is great. Now, the issue is sometimes you're broke as all hell, and you can't actually put down any collateral. You don't have anything to put anything down. But you see this arbitrage opportunity, or you see something like this, or you see some type of position where you need a lot of collateral quick. Wouldn't it be great if you could put $0 down? Yeah, that would be great, but that thing doesn't exist outside of the blockchain world. In the blockchain world, if you borrow money and repay it in the exact same transaction, Ethereum goes, yep, looks good to me, and the lending protocol goes, yep, looks good to me. Now in a flash loan, what I'll do is I'll borrow money, use that money to buy ETH, then sell that ETH for a nice profit, and then return the money all in the exact same transaction. And Ethereum allows this to happen because in that same transaction, Ethereum knows and Ethereum can test in code whether or not you can pay back that money in the exact same transaction. Oftentimes, the lenders have a really small premium and a really small fee for borrowing that in the first place, and they're happy because they're getting paid either way. So this is clearly a really powerful tool that we can use. We can borrow something with no money, almost no money. You got to pay a little bit of the premium and then also a little bit of the gas fees. So let's see what this actually looks like in code. So to get started here, per usual, we're going to do a git clone, and we're going to grab this Aave flash loan mix. If you already have Brownie installed, you can do Brownie bake Aave flash loan mix. I'm just grabbing from my repository because I've recently made a PR to the Brownie mixes here, and hopefully it gets added. But once we've cloned it, we will then have all the contracts in here. And again, don't worry if you don't have Brownie, it doesn't matter. All the contracts are going to be more or less the same, and they're all located here. We're going to be working with V2 of the Aave flash loans because V2 is, for lack of a better word, better. And in a lot of my coding tutorials, I actually walk through and code with you guys what's going on. But in this one, I'm actually just going to explain what's going on because for this one, it feels like it makes a little bit more sense to actually explain rather than walk through. In front of me, I have a contract that's actually going to interact with the Aave protocol. So if you haven't checked out Aave before, what are you doing? Aave is an absolutely fantastic protocol for borrowing and lending and doing fantastic, sophisticated DeFi work. They've recently integrated with Polygon, which is really exciting because gas fees are crazy cheap there. So if you haven't checked out Aave, definitely check out Aave. They are fantastic. And they have great developer documentation. So everything that we're going to be talking about is also in their documentation. But let's go back to the code. So we have to grab a couple of imports. We have to grab the Flash Loan Receiver base, iLending Pool address provider, and iLending Pool. Now, if these are a little bit confusing, don't worry too much about it. These two are just interfaces that we've imported in our Brownie thing. You can go ahead, if you're working with Hardhat, if you're working with Remix, copy paste them into your Remix, into your Hardhat, whatever you want to do. These are interfaces for the lending pool, address provider, and the lending pool. These are the pools in Aave that say, hey, we are the lenders. We will give out this collateral. We will give out this flash loan. We also import this flash loan receiver contract to make our contract a flash loan contract. And we also have this withdrawable inheritance. Don't worry about that. Flash loan receiver base is the more important one. It's saying our contract can do these flash loans. So in our constructor, when we get set up, all we got to do is give the address of the address provider. This is going to be this lending pool address provider right here. This is going to be the address for that lending pool. And if you're working with Brownie, you can actually find the ones for mainnet in here and also Coven in here. It's going to be the address of that lender. And that's it. That's the main bit that we need to do. Now, when we make a flash loan, now some of the code's a little bit abstracted here, but basically we have to write the functionality from making the loan and getting the funds and then repaying the funds in the specific function that they call. We have this function called flash loan, which all it's going to do is take the address of some asset. This is going to be some ERC20 asset, and it's going to ask for 1 ETH worth of that asset. So, one with the 18 zeros. I'm sure you guys have seen, me do this a whole bunch. But it's looking for 1 Ether worth of that token. So this is either 1 Chainlink, this is 1 wrapped ETH, this is 1 whatever. We're going to be working with wrapped ETH. So we're just going to be flash loaning 1 wrapped ETH. Now, in one transaction, we can actually flash loan a whole bunch of different tokens. So we actually have to add that to this array of tokens here. So once we decide, hey, we want, wrapped Ether, we want 1 wrapped Ether, let's add the wrapped Ether address to this list of assets, and we'll add the amounts to this list of amounts. Obviously, the 0th position of assets matches up to the 0th position of amounts. So if we put in the wrapped Ether address first and the amount 1 Ether first, we're saying we want to borrow 1 Ether from the Aave loan contract. Great. And then we'll call this flash loan function, which we scroll up, all it really does is call this flash loan with those 2 arrays that we just created. Now this flash loan function is the main function that we're going to be working with. And basically, it just grabs all the parameters together so that we can call this. This is the bread and butter. This is the one that's actually making the flash loan. So we'll do lending pool.flash loan, and the lending pool is going to be that address that we gave it, and this is the functions that it can call from. And you might be saying, oh, where is this lending pool thing defined? It's actually imported, so we don't have to worry about it. But this is the main function to call the flash loan. And we add the receiver address, which for our contract here, we're going to say this. So we want to send it back. We want to get the ETH into this contract. The assets, which is that list of assets, which for us is just going to be 1 wrapped Ether. The amounts, again, is just going to be 1 wrapped Ether. Modes are the ways to actually change between a no flash loan and a regular loan on the protocol. So if you do it says up here, if you do a loan of 1, you're doing a stable loan, 2, a variable rate loan. We want to be doing a flash loan, so we're just going to keep it 0, be no debt. But this is some good insight. If you wanted to do a regular loan, you could also code it like this. On behalf of, we're also going to say it's on behalf of this address. And don't worry about params or referral code. But this is the main function that gets called. So great. We're going to call this, and if we can, it's going to go ahead and give us 1 wrapped Ether. Now, how does it know if we can actually call this? Well, it's going to check to see if it can call this execute operation function and then get its money back. So the lending pool is actually going to call the lending pool is actually going to call this execute operation function here. So we need to actually approve the token transfer back to the lending pool so we can actually repay when it calls us. This is also the logic that we can add to do the rest of our functionality. And yes, we are paying the gas, even though the lending pool is the one that actually executes it. So this is where you can do whatever. You can do your arbitrage here. Do whatever you want. And you can see the inputs, again, are going to be the assets, the amounts, the premiums. This, if you want to learn how much it actually will cost, because doing these flash loans, the protocol actually does take a little bit of a fee in order to be this liquidity provider. It also gives the initiator params. Don't worry about those, but you can do whatever logic you want here. Now, once it's done, once you've done all your logic, you need to approve the lending pool to get the tokens back, right? Because the lending contract is actually going to call transfer from and try to get the funds back. And if it can't, it's going to null out your entire functionality. It's going to null out everything that you're going to do. So let's go ahead and see what this looks like. We're going to be testing this on the Coven network. Now, you do need a couple of environment variables here. Let's go to and we need to install Brownie and Ganache CLI. If you haven't already, you'll know you've done it if you can type in Brownie. And then also Ganache CLI. I'm so happy because pretty soon Brownie is moving to hard hat, which is going to be really exciting. We're actually going to be deploying to Coven testnet, so we don't technically have to do this Ganache CLI, but if you want to test locally, which you absolutely should, you will. Next, you'll have to get your Infura key. So you have to do this export web3 project ID is going to be your Infura key. And if you pulled from my GitHub or it was recently updated, you'll also have this .env file where you can put all these environment variables if you get a little bit confused on how those work. You'll need your Web3 Infura project ID. You can skip the Etherscan token for now. Don't worry about that. But you do need your private key. So we'll have to do export private key equals, whatever your private key is. Again, you can get it out of your MetaMask, account details, export private key. Just to note, you will also have to add this OX at the start of it if you're exporting from MetaMask. But once you've done all that, we're actually going to work with Coven, and we're actually going to deploy this actually to a Coven testnet so we can really see what it looks like, really see what a transaction looks like on Coven. So we will need Coven testnet ETH, which you can just head over to the faucet to get some Coven ETH. And you'll need to switch to your Coven testnet to see it in here. And what we're going to be doing now is we're actually going to be flash loaning for some ETH, for some for some wrapped Ether. So all we got to do now, and then once all your keys are in here, we can just run source.env. Now again, we are going to be doing this for Brownie, but again, these contracts will work the exact same in Hard Hat, Truffle, whatever you want to do. So you can just copy paste all the files into your hard hat, into your truffle, into whatever. Now, the first thing that we're going to do is we're actually going to run this script to get some wrapped Ether, right? So this is a script that I wrote. It just gets some wrapped Ether. So it's going to grab your key from your config, from your Brownie config, which you have set up with your private key. We're going to add the network, which we are going to be using Coven, and we're just going to deposit one ETH or one testnet ETH to get one Keith or 1K Ethereum, right? So you can make this less if you have less Keith and you don't want to mess with that, but this is what we're going to do. So we're going to do Brownie, run scripts, get WETH, or wrapped Ether, network Coven, and we're going to do a transaction. This is going to be on the Coven testnet. It's going to compile and everything here, and we're actually going to get one Keith. Now, I've got my one wrapped Ether. Now I've got my MetaMask up here. We see the one wrapped Ether has indeed come into my account here. And again, if you want to use the local net or the mainnet fork, you can absolutely do that as well. But now that we've gone ahead and do that, let's actually deploy this. So we're going to do Brownie, run scripts, deployment v2, because we're not screwing with the v1 stuff, -- network Coven. And this is going to deploy our flash loan contract. So if you're looking here, all it's doing, it's grabbing our private key and then it's deploying our flash loan contract using the Aave lending pool address, right? And again, we can find that in our config here. Since we're using Coven, here is the address of the Aave lending pool v2. This is the address right here. And then we also got wrapped ether using the wrapped ether contract address. And if you want to use, if you want to do a flash loan with something with Polygon, all you'd have to do is add the Polygon network. And great. And then the last thing that we're going to do is we're just going to run this flash loan script. So we're going to do brownie, run scripts, run flash loan v2.py, network Coven, and we're going to borrow one wrapped ether. We're going to do something with it, which we're not doing anything, but we could do something with it, and then we're going to get that one, then we're going to repay that one wrapped ether right back. And it even gives us the transaction that did the wrapped ether, that did the flash loan, and it looks like we're just, it's still going through. So once it actually confirms, we'll actually be able to see it, and we'll be able to see what this flash loan will look like in Etherscan. Now, one of the major benefits of us actually seeing the Etherscan here is we can now start to see, okay, this is what flash loan contracts even look like. This is what flash loan transactions look like. So if we look here, we can see that we did a couple of token transfers, right? So we borrowed, we got that one wrapped ether. But now, if we go back, we can see we actually got some wrapped ether, right? We got some wrapped ether in this contract. We got minted some Aave interest-bearing wrapped ether. And then we just immediately paid it back off, and we paid that flash loan contract back 1.00009 wrapped ethers, right? So this was the fee that we had to pay for doing this flash loan in the first place. And that's it. And now you know how to do a flash loan.